All right, 1.6, modeling linear functions. Here's a few things that we need to look at before we get into an example. If we are trying to write an equation of a line, then you should remember from Algebra 1, if you are given the slope, which is m, and the y-intercept, which is b, then you are going to use slope-intercept form, which is y equals mx plus b. Now, if you are given the slope m and a point x1, y1, then you will use point slope form, which is y minus y1 equals m times x minus x1. And lastly, for now, if you are given 2 points, x1, y1, and x2, y2, then you are first going to use slope formula to find m, and then use point slope form, with either given point. So you can use the x1, y1 or x2, y2, but you're going to go back up and use that point slope form that's up here. All right, so if you don't recall, your slope formula is m equals y2 minus y1 divided by x2 minus x1. All right, so let's go ahead and get started with our first example. These are all word problems. Yes, you must write every single thing on every single screen. You must write the whole problem. You must draw the graph. Every single solitary thing you must write. All right, so example 1. The graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of a line and interpret the slope. The asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? Okay, so just looking at a little bit of key information there. It tells us we have to write an equation. It tells us we have to interpret the slope. So those are two things we're for sure going to have to do. And then it says about how long does it take the asteroid to travel that distance. So that is all going to be together in that one answer. So there's actually 3 different answers that I should have here. All right, so first of all, if I'm going to write an equation, I'm given this graph over here. According to the previous slide, I would be given a slope and a y-intercept, a slope and a point, or 2 points. Well, from this graph right here, you can find out any and all of that information. Why don't we try to find a y-intercept and a slope just to make things a little bit easier for us. So y-intercept is where your graph crosses the y-axis. Well, it crosses the y-axis right there at 0. So our y-intercept is b equals 0. Now, if we're looking at slope, we are simply going to use rise over run. So if I'm looking here, let's go all the way to this point, just so there's no confusion with a different scale from our graph. So if I rise, well, I'm going to rise from 0 to 24. So my rise the whole way up would be 24. And my run the whole way over from 0 here to 5 is 5. So my rise over my run is 24 over 5. This is a real world problem. Anytime you have a real world problem, you may estimate and you may use decimals. So if we use rise over run for our slope, then we have 24 miles because our miles are on the y, over 5 seconds because our seconds are on the x, and that is going to simplify to 4.8 miles per second. All right, so now we have our y-intercept and we have a slope. And that falls into the very first equation from the first slide, which is going to be slope-intercept form. All right, so if we use slope-intercept form, we are starting off with y equals mx plus b. From here, all you have to do is plug in your number for M, which is here, and your number for B, which is here. So if we plug those in, we get y equals 4.8x plus 0. Now we can simplify that, and we will in a moment, but let's go back up and look real quick. It says write an equation, which we have now done, and interpret the slope. Well, if we are interpreting the slope, 4.8 is our slope from here, and we said that was miles per second because of our units there. So we can say that the asteroid is traveling 4.8 miles per second. So here's part of our answer of writing the equation. Here's another part of our answer of the interpretation of the slope. It's traveling 4.8 miles per second. And the last thing we had to do was estimate how long does it take the asteroid to travel that distance. Well, the distance they are talking about is, it says the asteroid came within 17,200 miles of Earth on February. Sorry about that. The asteroid came within 17,200 miles of Earth in February 2013. So we need to figure out 17,200. Well, miles is y. So we're going to need to plug that in our equation for y. So let's go ahead and do that so we can estimate. So we have 17,200 is equal to 4.8. To estimate the time it took, we're going to have to solve for x because x is our time. To do that, we are going to divide both sides by 4.8. When we divide, the 4.8's on the right side cancel, and we have 17,200 divided by 4.8. That comes out to be 3,583.3 seconds. Now let's think about that. Whenever are we going to say, oh, it took about 3,500 seconds to travel? We don't. We usually say it took 30 minutes, or it took 2.5 hours, or something of that nature. We will never say it took about 3,500 seconds or about 3,600 seconds. So, since that is the case, let's go ahead and change or convert that 3,500 or 3,583.3 seconds to hours. Now, if we do that, let's see here. All right, we have our 3,583.3 seconds. When you do a conversion table, so if you have done conversion tables before, some of you have not, when you do a conversion table, we are going to multiply those seconds right there by 1 minute over 60 seconds. That way, the seconds cancel. So if the seconds start out on top, they're going to now be on bottom. And so we've converted to seconds now. After that, we need to convert, we've converted to minutes. We need to now convert from minutes to hours. So right here, my minutes are on top. I need 60 minutes to be on bottom and 1 hour on top. That means I'm multiplying my 3,500 times 1 times 1, and then multiply 60 times 60. So that's going to give me 3,500 or 3,583.3 divided by 3,600. Go ahead and divide that out, and you're going to get 0.995 hours. Again, like I asked before, whenever are you going to say it took about 0.995 hours to travel? You're not. You're going to say it took about an hour, because that's very, very close to an hour. So the asteroid would travel 17,200 miles in about an hour. And that is the third answer that it told you to find. All right, that's all of example 1. Yes, it's long. Yes, there's a lot to it, but it's not too bad if you pay attention to what you're trying to find out. Let's move on to example 2. All right, take a moment and write example 2 down as I read through this. So 2 prom venues charge a rental fee plus a fee per student. The table shows total cost for different numbers of students at Lakeside Inn. The total cost Y in dollars for X students at Sunview Resort is represented by the equation y equals 10x plus 600. Which venue charges less per student, and how many students must attend for the total cost to be the same? So here in green, we'll highlight what questions we have. Which venue charges less per student? And then the next one, how many students must attend for the total cost to be the same? And that's talking about for each venue. So let's just make a little note up here that this is for Lakeside. So the table that they've given us is for Lakeside. And the equation that they've given us here is for Sunview. So let's go ahead and add Sunview into this table. So if you put in your calculator the equation y equals 10x plus 600 into the graph and press Control T, you will get out an equation, or I'm sorry, not an equation, but you will get a table that shows the numbers. Or you can just type in 10 times 100 plus 600, 10 times 125 plus 600, and so forth for these 5 values. When you do so, for Sunview, the equation that's given, we get this table here. So now they gave us an equation for Sunview. We've added that into our table as well, and it lines up with the x's here. So let's go ahead and make a note of the Sunview Resort equation, and that is y equals 10x plus 600. So then now let's look at the second set of information, and that's going to be for Lakeside. So to get an equation for Lakeside, we are going to have to do something that we don't normally do. We're going to have to put that in the calculator. So we've got a list of x's and we've got a list of y's. Actually, there's several ways we could find an equation. We can put it in the calculator. We can find a slope, find a y-intercept. We've got 2 points. Probably the easiest way is to go ahead and put that into the calculator. So let's pull up a calculator and see how we would go about that. All right, so here's our calculator. Now then, I'm going to give you several steps, and then here in a second I will have those steps all listed out for you so that you can make sure you make note of them, write them down in your notes. So for right now, we are going to go home on the calculator. We are going to click List in Spreadsheets, and we need to zoom out a little bit. All right, so now we're going to plug all of this information in for Lakeview, not necessarily just, we're not going to do Sunview, we have an equation for it. But Lakeview, we need to put in the x there and the y. Now let's put in our information. So on the x we have 100, 125, 150, 175, and 200. Then on the y, we have 1500, 1800, 2100, 2400, and 2700. Some of you may stop right there and leave your calculator just like that. It's not going to work. You're going to have to go ahead and press enter, and then make sure that you have that blue box below the last set of information that you have right there. So from here, we've put our data in List in Spreadsheets, and we are going to press Menu. We are going to press Data, and you notice down here there's Quick Graph. Sometimes it may show up grayed out for you, and then if that's the case, you need to go back and make sure your table looks like mine. So we're going to click Quick Graph, and we get a graph on the right side. When you get that graph, you need to fix your x and y. So x is the horizontal axis, y is the vertical axis. When we do that, it fixes our points perfectly like that. Now to get an equation, we notice from this graph that this is a linear function. So now we're going to press Menu. We are going to Analyze, and 6 is regression. We already said this is linear. There's two linear there. We want mx plus b because that's the form we use. Now, you may or may not be able to see the entire equation. If you see the little hand there, if you hold down, you'll be able to move. The hand typically will grab the equation on your calculator and you can move it wherever you need to. So now, we need to write that down. Y equals 12x plus 300. So let's move that calculator out of our way. And for Lakeside Inn, we have an equation of y equals 12x plus 300. So we got that information from the table, but sometimes it's easier to analyze things with a table, sometimes it's easier to analyze things with an equation. So the question here is, which venue charges less per student? Well, we need to know what information is giving us. So per student, well, if it says up here that there's X number of students, then the X is the number of students. So the 10 and the 12 is the charge per student. So which venue, if I'm comparing the slope of both, which venue charges less per student? Well, that's going to be Sunview because 10 is less than 12. So we are going to say that Sunview Resort charges less per student and make a note that it is actually $10. So there's our first answer there. Then the second question says, how many students must attend for the total cost to be the same? Well, for that to happen, we want these equations to be equal. There are a couple of ways that we can do this. I'm going to show you how to do this on the graph. You can do this on your paper as well. There's a little bit more room for error if you do it on paper algebraically, but let's do this with a graph. So we're going to go back home. We're going to choose the graph, and let's type these equations in. We have 10x plus 600, and we have 12x plus 300. Now, obviously, it's not showing us anything. If you pay attention, though, your y-intercept is at 600, your y-intercept is at 300. So you're not going to see anything there. So we need to zoom out a whole lot. In fact, we're just going to, instead of zooming out, we're going to click Window Zoom. And let's go to our Windows settings. So we can go from 0 all the way up to 1,000. And the same here. Let's go from 0 to 1,000. And then we're going to leave the Y scale to automatically fix and the X scale as well. All right, now we see a little bit more going on there. So maybe we need to drag that graph over. Let's kind of drag it around a little bit. And you can do this on your calculator as well. See where it's going to fix or where it's going to cross. Now you see right here, they kind of tend to cross right somewhere around here. Is it going to be easy to find just looking at it? No, probably not. But if you go to Menu and you go to Analyze Graph, number 4 is Intersection. So click Intersection. You see this dotted line. Lower bound is going to be on the left side. Upper bound is on the right side. And looky right there. You have 150 and 2.1e plus 3. I'll tell you what that means in just a second. But that's telling us right there they do cross when x is 150. So in that 2.1e plus 3, let's go ahead and just plug 150 into one of our equations. So let's go home, go to the calculator screen, and we will type in 10 times 150 plus 600. We get 2100. Just to double check, 12 times 150 plus 300. They both give us 2100. So we can now say that 150 students must attend for the cost to be the same, which is $2,100. So there's our questions answered. All right, moving right along. We have a little bit of information here. Yes, you need to write all of this down. Step 1, create a scatter plot, which we've done. Step 2, sketch the line that most closely appears to follow the trend. We're doing all of that on the calculator. Uh, choose 2 points on the line to estimate, write an equation. All of that stuff's on the calculator. So, yes, you do have to write that down. And then go ahead and pause and write that down and then press play because here it is. Put data in spreadsheet, X and Y also. So your list in spreadsheets is where you go, input that information. You're going to go to menu. Choose 3, which is data, 9, which is quick graph. You will fix X and Y. You choose menu again. 4 is analyze, 6 is regression, 1 is linear mx plus b. That's supposed to be a plus, not a t. Sorry about that. All right, so that right there is going to be exactly what you do. Make sure you write down all of those steps and make sure you keep those. Maybe you may need to put a tab in your notebook so that you can keep those handy. All right, so let's move on to the last example here. Yes, it's a word problem just like the others, but this is the last one. The table shows the femur lengths in centimeters and heights in centimeters of several people. Do the data show a linear relationship? All right, I spot an question there, a question, sorry, so I'm going to go ahead and highlight. If so, write an equation of the line of fit and use it to estimate the height of a person whose femur is 35 centimeters long. So there's a few things we need to do here. And right over here, we're given femur length and height. So, do the data show a linear relationship? Well, the easiest way, and there's a lot of data there, the easiest way to do that is going to be to put it in the calculator. So let's go back to our calculator, go back home, go back to the spreadsheet, and you notice you may have several things open there. We're going to close that and hit no. So then now we're clear. We're going to start with X at the top and Y at the top, and go ahead and plug in all of those X's. So we have 40, 45, 32, 50, 37, 41, 30, 34, 47, and 45. Now go ahead and type in all of your Y's, 170, 183, 151, 195, 162, 174, 141, 151, 185, and 182. I know you don't have one of these calculators at home with you, but you do have one in class that you can go back and plug these things in to look at all of this information. Just like I said before, make sure you hit enter on the last one so that your cell below the number is the one that's blue, that's highlighted. All right, now let's go ahead and follow all of that information that we wrote down on the last slide, because our question is, do the data show a linear relationship? Well, let's go ahead and get a quick graph. So again, menu, 3, 9, fix the X and Y. X is horizontal, Y is vertical. All right, is that a linear relationship? Well, it might not be exactly linear, but is there a linear relationship? Yes, there is. All right, so then write an equation of the line of fit. I kind of showed you that already, but just to make sure we go back here and get that, again, we're going to go to menu, 4, 6, 1. And we're going to move that so we can see all of it. We're going to estimate. So we have y equals 2.6 x plus, and that's a 64.9968. Basically, that's going to be 65. So there you go. Y equals 2.6x plus 65. So that answers my first two questions. Do the data show a linear relationship? Yes. If so, write an equation. And there we go. Now, use it to estimate the height of a person whose femur is 35 centimeters long. Well, if I scroll back up here, my femur length is x. So really, all I have to do right here is to go ahead and plug in 35. So I have y equals 2.6 times 35 plus 65. And when you put all of that in your calculator, 2.6 times 35, and then add 65, you're going to get 156. So that means if you have a person who has a femur of 35 centimeters long, then they are going to be about 156 centimeters tall. Make sure you write your answers in full sentences, just as I have here in our notes. A person whose femur is 35 centimeters long will be about 156 centimeters tall. And not as quick as I would have liked it to be, but that's our last one. 25 minutes. It's knocking it down just a little bit from 30. So we're all done.